This video is on triangle similarity. We're given the proofs of the triangles being similar, and we're going to write the analysis of it. So basically, we're going to write it as almost like a paragraph proof. The first one, we're given that MN over PR is equal to ON over QR, and that angle N is congruent to angle R. And we want to prove that triangle MNO is similar to triangle PRQ. So we have the fractions are equal to the fraction, that's our given. We're given an angle is congruent to an angle in our given. So we have two fractions and we have an angle, therefore we should have side angle side. So since we're going to talk about this in regards to actual proportionality. So since MN, segment MN, and segment PR, because we have MN over PR, have the same ratio of similarity as segment ON and segment QR, which the ratio of similarity just means that they are proportional. So when it says ratio of similarity, it's the same thing as ratio of proportionality. So this is the same thing as proportional. It means that the fractions are proportional, sides are proportional. So since we have these sets of sides are proportional, and angle N is congruent to angle R, then triangle MNO has to be similar to triangle PRQ by side angle side. Similarity. That's the difference between congruency and similarity, is because we have proportionality instead of congruency. That's the main difference between our sides. We would still have if we had congruency, these sides would have to say they're congruent. So technically we have MN over PR, so MN and PR would actually need to be the same color because those are proportional to each other. And then ON and QR. So ON and QR would have the same colors because those are proportional to each other. They have the same ratio of proportionality. On the second one, we're only given one thing. So we're given that angle S is congruent to angle W. So we only have that one piece of information given to us. Since we don't have any fractions given to us and we don't have any values on our picture, that actually tells us that none of our sides will be proportional. We have to be given that they already are proportional, or we have to be given side lengths. Since we have no numbers on here, there is no way we can prove side, 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 or side, angle, side similarity. The only thing we could prove is angle, angle similarity. So we have one angle, we need to prove a second angle is congruent. And as they touch, so angle SUV, and angle WUT have to be congruent because of vertical angles. So we can actually mark that these two angles are congruent because of vertical angles. Now we have two angles congruent, and that's all we can prove because we don't have anything else. We can say that these two triangles are similar to each other. So since we have two angles marked congruent, now that we have the two angles marked congruent from the given and our vertical angles, we have similar triangles by way of angle, angle. Because we can't prove anything else, we can't prove the triangles are congruent, but we can, in fact, prove that they're similar by angle, angle. And this next one, we're actually given parallel that says AB is parallel to DC. So in our given, we will say that AB is parallel to DC. However, when you see that word parallel actually means that angles are congruent. Angles are congruent. Parallel gives us the angles are congruent because if we remember, We could have the alternate interior angles. When we have that Z, it's those corners. But we could also have the corresponding angles. Corresponding angles come from that letter F or like an E, and it's those corners. But it has to be, make sure you have the bottom corners. So if we look here, we do have the parallel lines, and you can see that in our proof, it actually says corresponding angles. Since it says corresponding angles, that means that we have the letter F. So here are our, if we look over here, we have those parallel lines, and to form that F, we have this transversal, so it's these corners right here are congruent. So we have angle A, because there's only these two lines that go to A, but we had to use angle CDE here because there are multiple lines that go to this letter D, which is why we have to use 3 letters here. There's only 2 sides or 2 lines that go to A, but there's 1, 2, and 3 sides that go to D. That's why we have to use 3 letters. So you could have said EDC or CDE. As long as D is in the middle, I don't care which one you use. So CDE, that's what they used. So these are congruent because of corresponding angles. Now on this other, we also have corresponding angles here. So that means that we should have these parallel lines, and then this transversal will also make the F. So it's these 2 angles are congruent. So again, angle B only has these 2 sides going to angle B. That's why we only have to use 1 letter. But here, there's multiple lines going to C. We have 1 line here, 1 line going that way, and then this line. So that's 3 lines. So we have to make sure we name it appropriately with 3 letters. You can name it DCE or ECD, either way. So they named it DCE because of corresponding angles. There are no fractions in our given, and we have no side lengths. Therefore, we cannot say anything about proportional. We cannot do side, 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 or side, angle, side. We have to use angle, angle. So on here, for our analysis, we can say that parallel lines give corresponding angles which were the angle A is congruent to angle CDE, and angle B was congruent to angle DCE. Those were the corresponding angles. That means, so since we have the 2 angles, that means we can say that triangle ABE is similar to triangle DCE by angle similarity. So make sure we put that these are similarities. So by way of angle similarity, side similarity, side similarity. So it's all done by similarity. Because we cannot prove anything else. We cannot prove that these are reflexive. The sides aren't congruent. We don't have any measurements. However, you can actually prove, do you see how these 2 triangles are, this little triangle is actually apart, like set straight into this bigger triangle? We could actually say that angle E is congruent to angle E because of the reflexive property. Reflexive property, again, states that the entire side or the entire angle is connected to each other. So the angle E on the little triangle is sitting inside of the angle E of the bigger triangle. So this angle right here is actually congruent to itself on both triangles. So we could have used the reflexive property instead of corresponding angles twice. We could have used corresponding angles once and then the reflexive property for the second one.